Let's understand the meaning of parametric equations first, and then we solve these sums based on that. I have drawn a circle here, which is the center is 0, 0, and a point there x and y. Our aim is to find the x and y values in terms of a kind of angle, say, right? So what I'm going to do now is I will draw the height from A onto the x-axis there, and I'm going to call this angle as theta, right? It can be degrees, radians, it doesn't matter now for the time being. Using, well, this value is x now because that's the x-axis number, and that is the y value, which is the y. Using the triangle, we need to find the x and y values. So sine theta, I can say sine theta is equals to opposite side, which is y, and divide by hypotenuse. Let me call it, say, k, right? So hypotenuse is k. So what we have y is equals to k sine theta. K is any number, right? That's the radius of the circle. Now let's look at the next value. Say we need this one, cos theta. Let's write cos theta there and see what happens. Cos theta is adjacent side over hypotenuse. So it's x over k. So if you make x a subject, we got x equals to k cos theta. These are the two equations there I want you to keep in mind. Y equals to k sine theta and x equals to k cos theta. So the point A has coordinates x and y, that we know, right? But I can change the coordinates now using those two, right? X equals to k cos theta, I can say, and y equals to k sine theta. So they also show the coordinates there, depending on the value of theta. Now this red line there, the radius, moves around the circle, so the angle will increase gradually. So we can understand where the point A is, and we can find the x coordinate or y at any time as long as you know what is theta value. So these two equations now, x is expressed in a third letter as a function of theta, and y is also expressed as a function of theta. These two equations are called parametric equations. That's all it is, parametric equations. Okay, so this letter, the third variable, x and y are two. The third one is theta. That theta is called parameter, right? That's it. So textbooks use theta or maybe t, doesn't matter. They will write x equals to k sine t, y x equals to k cos t, y equals to k sine t. So we understood the meaning of this, right? So these two equations, we call them as that. Now if you study one more example here that I have written for you, I have a curve. I don't know the name of the curve, right? But I do have the x coordinates of the curve and the y coordinates of the curve. So what we can do, if you take all the x coordinates and write at one place, watch there, 4, 5, 6 and 7 and 8, it goes on, suppose. Using these x coordinates, let's find the nth term. So difference is 1, 1, so we know Tn is equals to n plus, right? If n is a 1, then that should be a 3, isn't it? So what happened? We got an nth term for the x coordinates. So what the textbooks do, or they say x is equals to t plus 3. That's what they say. So if you put t as 1, you have 1 plus 3, 4 there. Put a 2, 2 plus 3, 5. So this will define the x coordinates. So this is a kind of nth term for the x coordinates. Now let's take the y coordinates and study what happens. The y coordinates are 1, 5, 9, 13. So let's write 1, 5, 9, 13. And we all know how to find the nth term from C1 or GCSE. The difference is a 4 there, right? So the nth term for me, I got as 4n and say minus 3, right? 4 times 1, 4, minus 3 is 1, 4 times 2, 8, minus 3, 5. So this nth term will give me all those numbers if I change the n value. So these are actually the y coordinates. So I can say y is equals to 4t minus 3, right? So x equals to t plus 3, y equals to 4t minus 3. These are the two equations that describe the x and y coordinates of a given curve. These two equations, in the x and the y, they are expressed in a third letter as a function of t, and we call them as parametric equations. That's all it is, right? That's parametric equations. If we know the curve in x and y, in the last case, we know actually this is the circle, the equation of the circle. We all know x squared plus y squared is equals to r squared. So that's called a Cartesian equation. Cartesian is in x and y, okay? And this one is in some other letter. So that's the meaning of the topic. So please understand the x and y that they give you, which we call as parametric equations, are nothing but the nth terms of x and y. Okay? We can convert parametric form into Cartesian form and Cartesian back into that. We will do a few sums on that. Before that, let's see how to sketch these curves. So I have a question here, very small one, sketching the curve now. I'm not going to spend much time on this, right? So a curve is defined parametrically, that's what they say. X equals to t square, y equals to 2t. So that's the nth term of the x coordinates, that's the nth term of the y coordinates like. So to draw the graph, we don't have a t-axis, we got x-axis and y, right? So we take the t values as we like, say, right? 0, minus 1, 1, 2, minus 2, etc. We substitute them in those two. If t is a 0, I have x coordinate 0, and if t is 0 for y coordinate is also 0, so I do have a point there, 0, 0. Then I substitute minus 1 there. So x coordinate becomes 1, y coordinate becomes minus 2, right? So we have 1 and a minus 2 somewhere down there. In the same way, if you substitute 1, x becomes a 1 and y becomes a 2. So we have a mirror or the reflection of that point here. Let's substitute minus 2. Substitution, minus 2 square gives me a 4. That's the x coordinate. And minus 2, I got a minus 4. For a 2, I have a 4 and a 4. So we have 4 minus 4 and 4 and a 4. So basically we are looking at a curve, a U-shaped curve sideways, right? That's how the curve looks in a Cartesian plane, that's xy plane. This is actually called parabola, right? That we know. So sketching of the curves is like this. So take the values of t, negative and plus, substitute into the parametric equations given to us, and we get we get the respective x and y coordinates. So if you need a point, the point is 1, minus 2, 0, 0, 1, 2. That's what it means. So sketching these curves is pretty easy. You can do them at your own time, right? Once we completed that, we are looking at the changing from parametric form into Cartesian form now. We understood the meaning of parametric equations. Very, very important. The x and y are expressed in another letter as a function. Okay? We are going to study now about changing from one form into the other. We take one example, which is here, parametric and Cartesian form. Cartesian, please understand that's xy plane. Parametric, x and y are expressed as a function of a third letter. It can be t, theta, anything. I have x equals to t plus 3, so that's the nth term. Y equals to 4t minus 3, nth term for y coordinates. My plan is to eliminate t. That's it. So remove t. From the first equation, if I make t subject, I have x minus 3. That's what I'm going to substitute back into this equation now. So I have y is equals to 4 times t, which is that, minus 3. So I substitute that as x minus 3, I get 4x minus 12 minus 3 minus 15. So it's actually a straight line, y equals to 4x minus 15 with a gradient 4 in Cartesian form. In parametric form, the curve was x equals to t plus 3, y equals to 4t minus 3. Right? That's how. So go to x most of the time, make t subject if you need the answer as y equals to. I'm looking at the second one now, which says x equals to 3t. So make t subject, we have 1/3 x or x over 3. That's what you substitute in place of t for y. So y equals to t square, which is x square over 9. Right, so it's a 1/9 x square. That is the Cartesian form of the parametric equations which we have. That is how you convert one into the other. The third sum is here. You try that please. Question number 3. It says x equals to t square minus 4. Let's make the t square subject, right? T square equals to x plus 4. Luckily, we have a t to the 4. So what we can do, don't make t subject. You will get a root there. It doesn't matter, but still this is very easy to do. T to the 4 we can write as t square whole square. That makes sense, isn't it? So now half is a half. T square we already know as x plus 4. So we'll write x plus 4 whole square. You can expand it, divide by 2 or leave it like that. Okay. So that's the Cartesian form of that. Then the fourth one we have, it is always nice to know the shape of the curve, right? If you expand it, we'll get x square. So we are in a U-shaped curve. And this question, we have x equals to 4 over t and y equals to 3t. Let's make t subject. T is equals to 4 divided by x, you all know, and put that value back in here. So we got y is equals to 3 times 4 over x, which is actually 12 over x. We are looking at a hyperbola. Sorry. So changing one form into the other, very important to know, and recognizing the shape is also very, very important. X equals to t square minus 1. And it's a t cube. In the last case, it was a t to the 4, so it was easy. But now it's a t cube. Let's make t square subject from there. So we have t square equals to x plus 1. And t is equals to x plus 1 to the power half or maybe square root. That's what we substitute in here. So if we do that, y equals to t cube plus 1. So y is equals to t cube. So this is what you got to write, which we have x plus 1 to the power half and to the power 3 because it's a t cube. So that's a cube and it says plus 1. So the final answer should look like x plus 1 to the power half times 3, 3 over 2 plus 1, y equals to. So that's the Cartesian equation. And these two are called parametric form. Okay? Right, that's the answer. That's the Cartesian form of the given question. We have one more here. Could you please copy that and solve it? And then you check the answers, please. X equals to t minus 1 implies t equals to x plus 1. Put that back into the y parametric equation, which is x plus 1 and says a whole square plus 1. It's lovely. X square plus 2x and plus 1 plus 1 plus 2. So it's a quadratic, and in parametric form, see how it looks like. In Cartesian form, we know exact shape it is. But if you use them to draw the curve, you definitely get the same curve. Question number 7, please. That's the question, which is t squared minus 3 and t minus, sorry, 3 minus t. Subject, which is t square equals to x plus 3. Make t subject because we don't have a t square there. It's a square root of x plus 3 or whole to the power half. So we got y equals to 3 minus the t is actually square root of x plus 3. You can leave the answer like that, nothing wrong, or maybe to the power half. Okay, we are doing converting from parametric form to Cartesian form, please. Very important concept. We have x equals to 3t square minus 2. That's pretty easy because both are t squares. Implies 3t square equals to x plus 2. X plus 2. And t square is 1/3 x plus 2. You don't need to make t subject because we already have it here. So now I'm going to write y is equals to 9 minus t square is that square. No. So it's x plus 2 divided by 3. But this is where I want you to listen. You mustn't leave your answer like this. There is a little bit more to it. 3 9s 27 and minus x minus 2. You all know how to take the LCM. Then we divide by 3, divide by 3 and divide by 3. So 27 minus 2, 25. I can say minus x over 3 plus 25 divided by 3, y equals to. So that's the proper form. Now it looks like y equals to mx plus c. We know the gradient minus 1/3. So the Cartesian equation of that parametric form is actually a straight line with a gradient minus 1/3. And the y-intercept, please, is 25 divided by 3. Fancy this, please. That's x equals to 2 root t, and we can make t subject. Let's open the bracket here actually to see what happens. 90 minus t square. Okay. Now we go there, make t subject. Root t equals to half x or x over 2. Remove the root, so t is equals to 1/4 x square. We know we multiply, say we square on both sides to remove that. Then the root. That's what we substitute here now. I have a 9t, means 9 times 1/4 x square. Then we have minus t square, we square that, which is going to be 1 over 16 x to the power 4, right? That's the Cartesian equation of the given question. There are lots of questions in your textbook. Please try and solve each and every one of them. Important sums, please. This one is a fraction. Let's see how to do that. We have x equals to 1 over t plus 1. That's the y parametric form. Convert to Cartesian. Let's take t plus 1 here. Just do the normal algebra you should be able to do. T plus 1 is equals to 1 over x. Understand that. And t equals to 1 over x minus 1. Let's simplify this. It helps us. Or maybe you can use that there so that the 2 and the 1 can cancel. That's another way to do. So let's substitute this value there. So y equals to 1 over, watch that, t is a 1 over x minus 1. And there is a minus 2. That's what I meant. So now it's 1 over 1 divided by x minus 1 minus 2 minus 3. You can simplify this and make it upside down. Done. Okay. So that's over 1. We are supposed to get 1 over 1 minus 3x divided by x. If you take the LCM. Because it's 1 over, the final answer should look like y equals to x over 1 minus 3x. All right, that's y please, y equals to. So that's the Cartesian form of the question. Just be careful about the LCM stuff there. And 13th question here, please, that's on the screen. X equals to 1 plus t and 1 minus t over. There is a 1 minus t here. Nice, really. 2 plus t. There are 2-3 ways to do. What I want to do is, maybe I split this, make it look like that, because they're almost the same. Like the 2 plus t we can write as 1 plus t. Watch. And divide by, we have a 1 minus t. Split this fraction, the 1 and 1 minus t separately, and then say plus 1 plus t over 1 minus t. Guys, listen, you can just do the cross multiplication, make t subject, and you can do that way as well. But I'm trying a different method to see whether it works. Now that is exactly same as x, so that is exactly same as x. So that can be replaced by x. We still need to know what is t, or 1 minus t, right? So we go back here. Now let's do the cross multiplication. X times 1x minus xt is equals to, very important one, please, 1 plus t. So take the terms to the left hand side. You know how to make t subject. X minus 1 is equals to t plus xt. Take t common, we have 1 plus x, and that's x minus 1. Right? So t equals to x minus 1 divided by 1 plus x, or x plus 1. Okay, this is what we substitute in place of t there to get the answer. This we already know as x, right? You can do the way you like, please. It's still the same, okay? Now, I want to do what is 1 minus t first, so that we get 1 over 1 minus t. Watch here. 1 minus t is 1 minus x minus 1 over x plus 1. Take the LCM, please. That becomes x plus 1 minus x plus 1. If you open the bracket with negative, we got x plus 1. Simplify that. 2x plus 2. No, x's can cancel, please. It's a 2 over x minus 1. That's the value of 1 minus t. So go back there. That is 1 minus t. So it's 1 over that fraction. So in the end, what I suggest is, your question was looking like 1 over 1 minus t plus 1 plus t divided by 1 minus t. That's how it was looking there. Watch, right? I'm going to substitute. This whole thing is nothing but x. See, that's 1 minus t over 1 plus t over 1 minus t is x. So substitute that back, and plus this one we already done here. Watch, 1 minus t we know. Now 1 over 1 minus t means this fraction becomes upside down. So it's x minus 1 divided by 2 over 1 there. Left hand side is y, please. And that's a lovely straight line, looks like. So it's x minus 1 plus 2x divided by 2. So that's in fact 3x. So it's a 3 divided by 2x and minus a half. Sorry. So that 2 belongs to the top. That's a 3 over 2x minus 1 over 2. That's just x, please. So finally, it's just a straight line. But in parametric form, that's how we can show. All right. So that's one of the exam questions they gave you to convert. Now, this is based on algebra. What happens if it's not algebra and we suddenly move into trigs? We still need to know all the rules from C3, C4, right? The sine, cos, tan, sec, the double angles, the basic fundamentals. Everything must come back here to actually solve these sums. We got the first one as x equals to 2 sine t, y equals to 3 cos t. The moment you see sine and cos, we are in sine square theta